Many products that you buy and use each day have a label with the words danger, warning, or caution at the top, although only one of the three literally has the word warning on it. These labels are all generally called warning labels. A warning label is a label that contains information about the proper intended use of a product and information that you need to know to use the product safely. You should read all warning labels prior to using a product. A warning label generally consists of three main parts. 1. The signal word, which is the word danger, warning, or caution. 2. The statement of hazard, that consists of one or more statements about the potential hazards to which you may be exposed when you use the product. And 3. The hazard avoidance instructions, that are the safety precautions you should take to protect yourself from the hazards. You may also see references to other safety materials such as the manufacturer's instructions for the product, OSHA regulations, and industry standards for safety. This information is too much to put on a label, but can be obtained and reviewed in the reference materials if you want to know more details about using the product. Additionally, there may be other supplemental safety information on the product package or label you should read as well. You have seen warning labels on the arc welding and cutting products that you use. You can find warning labels on the following types of arc welding and cutting products: arc welding equipment, including arc welders and wire feeders, arc welding electrode and flux products. The warning on the arc welding equipment that you use does not change unless you change the equipment that you use. It is good practice to read the label when you first use the equipment, and after that to refresh your recollection or when you have a question. This is a typical warning on a piece of arc welding equipment. It covers the basic hazards encountered in arc welding, such as exposure to arc welding fumes and gases, electric shock, arc rays, and fire and explosion. It also instructs the welder to read and follow the manufacturer's instructions and refers the welder to both the OSHA regulations and the American National Standard regarding arc welding and cutting safety, ANSI Z49.1. You can also find the OSHA regulations, including those that cover arc welding and cutting, as well as ANSI Z49.1 on the internet at www.lincolnelectric.com or on the U.S. Department of Labor OSHA and American Welding Society websites. You do not have to read these references each time you weld, but you should look at them at least once a year. The warning on arc welding electrode and flux products may be different depending upon the product you are using. Warnings on electrode and flux products are also updated occasionally, so it is a good idea to review them again periodically to be sure you have the information you need to use the product safely. The warnings also vary from product to product, so when you change the product you are using, you should review the warning on the new product when you begin to use it. Product labels may also contain additional safety information or warnings. This is particularly true of electrode products that may also have supplemental warnings regarding cancer if required in California. They may also have special ventilation notes that inform the user that a particular substance in the electrode is in sufficient amounts that additional ventilation is needed to properly control fume exposure. Special ventilation notes commonly relate to manganese and chromium in the welding fume. However, other substances may also require such notes. Special attention to ventilation is important when welding with products having such notes. You are very familiar with a number of common fuels which are combustible or even explosive, such as gasoline, diesel fuel, kerosene, propane. Of these, gasoline is the one with which everyone has experience. This useful fuel is used in your lawnmower, chainsaw, family car, even your welder in many cases. It is also likely that you have heard or seen the results of a gasoline fire or explosion. Always remember that the small amount of gasoline which explodes each time a cylinder fires comes from a storage tank located nearby. Listed below are some safety precautions you must follow when using engine-driven equipment. Do not fill the fuel tank with the engine running, particularly when the fuel is gasoline. There is no good reason not to shut the engine off when refueling. Do not smoke when fueling or when near fuel. If you need to smoke, take a break away from the refueling area. Avoid sparks and open flame when fueling. Remember, the arc is a source of sparks. Keep it away from the fuel. Do not spill the fuel. If you do spill it, wipe it up. Don't allow puddles of fuel to develop because of a spill or leak. After wiping up the gasoline, dispose of the rag as a hazardous material while it dries and wait a minute or so until the fumes from the fuel clear. Nature has provided you with a sensitive fuel sensing device, your nose. Note, please follow your employer's guideline for disposal of waste materials. Shut off the fuel at the fuel tank or sediment bowl while moving your engine-driven welder. This reduces the potential for a fuel leak as you travel. Your welder has been designed to minimize the possibility of a fire caused by an internal fault. There is little inside which will easily burn. However, you should be sure that you follow the installation and maintenance instructions provided by the manufacturer. Be sure the wiring is fused and grounded properly. Refer to the National Electrical Code and any local requirements. There are two other sources of sparks which you should know about: engine exhaust sparks and internal electrical sparks. If you have looked closely at an engine after dark, you have undoubtedly seen the exhaust glow and may have noticed a spark or two rising a short distance from the exhaust pipe before disappearing. Normally, these sparks will not be a problem because they cool rapidly. However, under some circumstances, they may pose a fire hazard. Some governmental regulations may require a spark arrestor, which will trap sparks. This is a particular concern and is a requirement in dry forested areas where a fire can easily be started, and locations such as in offshore oil rigs and refineries. Know where a spark arrestor is required and install it. Your arc welder and most other electrical equipment contain switches, relays, and brushes, which create very small sparks when operating. There is no fire hazard associated with these sparks under normal circumstances. However, no general-purpose electrical equipment, especially arc welders, should be used in any location where an explosive gas is present or can escape. Special safety precautions must be taken, and a hot work permit is generally necessary when welding under such conditions due to the serious hazard. Perhaps you have noticed the warning about moving parts on your welder and thought it unnecessary because it is only common sense. We agree it's common sense, but don't skip to the next topic just yet. As a welder, you are interested in welding, but remember, you also must operate a welder which has moving parts. In a welder, there may be many moving parts, but we are concerned primarily with the cooling fans, which offer the most serious risk of injury to you, the welder. When working in and around equipment which is a cooling fan running at high speed, it is important to be careful, especially when you're working near those parts. Equipment is enclosed to protect you from moving parts, but as you know, sometimes it is necessary to open the enclosure to operate or service the equipment. It is when you open or remove the enclosure that you expose yourself to injury from a moving part. Please follow these rules. You may prevent an accident someday. Rule number 1. Turn the engine or power off before working on a machine unless the work requires it to be running. Don't be lazy at the expense of safety by not shutting the welder down when you must service your equipment. In addition, it is wise to disable the machine by disconnecting the engine ignition, battery, or input power. Rule number 2. If it ain't broke, don't fix it, and if you don't know, don't touch. Your welder is a reliable piece of equipment, but even the best welder will require service at some point in time. When you believe there is a problem with your welder, have a trained repair person check it out. If you insist on doing the work yourself, get your operating manual out and check the troubleshooting section for your problem. If you don't understand the manual, then find a trained serviceman. Don't fool yourself by thinking you can tinker with the welder and somehow solve the problem. Injuries can occur when this happens. Rule number 3. Keep the enclosure on your welder intact, even if it means you replace a panel or guard, which you may have to remove again. Following this rule may cause you some inconvenience, but it may also prevent you or another worker from being injured. Don't be the one who removes a guard and causes another person injury. Rule number 4. Always use safe work habits and be especially careful when you must service a machine which is running. First, only work on a machine if you are qualified to do so. Even if you are qualified, only work on a machine which is running if that is the only way to perform the work. As a welder, You will probably not need to work on a welder with the engine running. Leave that to the repair shop. If the machine is not working properly, don't use brute force. That never solves the problem. Problems are only eliminated by adjustment and/or replacement of a part. Too many times, an individual will use force and slip, causing injury to himself. An example of this is an operator who tries to force the carburetor governor linkage on a gasoline engine welder. In such cases, the problem is usually at the idler or carburetor, not the governor. If brute force is used when the problem is not understood, someone may be hurt. Rule number 6, read, read, read. It seems that we never have time to read the manual. Don't try to learn the hard way when someone has taken the time to write it out for you. Take the time to get the manual for your welder and read it. At the same time, read any warnings or instructions attached to the machine. This information has been provided for your benefit, but is useless unless you, the welder, read it. No matter how unnecessary the warnings or safety instructions may seem to you, for each one there is a potential for injury if ignored. We hope you have been thinking about your working habits and your welder while reviewing this section. Do you measure up? If not, then change your ways and prevent an injury. If you own or operate an engine welder, look at the area around the cooling fan. If there are no sheet metal guards bolted in place on either side of the cooling fan and radiator shroud, contact your Lincoln Electric representative, distributor, or service shop to order the proper fan guards. Remember to write down the welder model, code number, and serial numbers so the proper parts can be specified. If other equipment you work with lacks guarding, consider obtaining guards from the manufacturer. If they are not available, make your own. Of course, the manual for your Lincoln Electric welder is available on our website at www.lincolnelectric.com upon request, should your original have disappeared. Portable power generators, including welders with auxiliary power capability, are commonly used on construction sites and other outdoor work areas where the additional protection from electric shock provided by a ground fault circuit interrupter, GFCI, may be an OSHA requirement. Under certain conditions, an electric shock from 120 volts AC can kill depending on the length of the shock, path of flow through the body, amount of current, and the surrounding, i.e. damp or wet conditions. In many cases, an electric shock is received where a person touches a hot lead and ground. When this occurs, the current causing the shock leaks into the ground circuit. GFCIs monitor current flowing through the auxiliary power lines for leakage to ground, and they quickly turn off the electric current when they detect even very small leakage currents. GFCIs are more sensitive than other devices such as circuit breakers and fuses, and should prevent you from receiving an electric shock caused by ground fault. While GFCIs greatly reduce the likelihood of a dangerous electric shock when using equipment powered by a generator, you should understand the following limitations of GFCIs. The 120-volt GFCI offers no protection for 240-volt receptacles. GFCI will not prevent a shock if you touch both hot leads. A GFCI will not protect you from receiving a shock from the welding circuit. Standard safety precautions to protect against electric shocks must still be followed even on GFCI-equipped machines. In most situations involving the use of portable generators, including on construction sites, OSHA regulations and the U.S. National Electrical Code require the GFCIs be installed on portable or vehicle-mounted power generators with 120-volt AC receptacles. For many engine-driven power sources, GFCI kits are available from the manufacturer. Many engine welders come equipped with tow or more rectangular 120-volt, 20-amp duplex receptacles. There are also other commercial GFCI units available that may be installed or plugged into the receptacle. In any event, GFCI should periodically be checked for proper operation when installed as well as while in service. Test and reset buttons on the GFCI are for this purpose. When portable engine-driven power generators welders are used to provide 120-volt power in construction or other outdoor locations, you should determine if ground fault current interrupters are needed. According to OSHA regulations, it is the employer's responsibility to provide GFCIs on construction sites, and if your welder is on a construction site, you may be the employer. OSHA inspectors check for GFCI on portable generators, so be warned. Space limitations will not allow us to fully cover all federal, state, and local regulations pertaining to the use of GFCI on auxiliary power generators. Our goal is to help you understand a little bit about GFCIs and when they may be required on 120-volt portable generators. For further information, write to OSHA for the following pamphlets: Ground Fault Protection on Construction Sites, OSHA 3007, Electrical Standards for Construction, OSHA 3097, and Controlling Electrical Hazards, OSHA 3075. There are 3 types of electrical connections that will be discussed. 1. Earth ground. 2. Chassis ground or frame ground. 3. Welding ground or work cable. First, let's discuss the earth ground. This type of ground refers to a direct electrical connection from the frame of some electrical equipment or fixture to the earth, and is indicated at the connection by the symbol or by a green-colored screw. Earth ground. Electricity is lazy and always chooses the easiest path to follow, in this case, the short to ground, so high currents flowed to the earth ground, causing the circuit breaker to trip. Remember, electric current always tries to seek ground through any conductive path available, and your body can be part of that path. When the ground lead is connected properly to the metal frame, there is always a safe path to ground, waiting for electric current to flow should a fault occur. The earth ground connected to the metal case protects you from electric shock caused by a fault inside the device. Be sure your equipment is grounded at the screw-colored green or marked with earth ground symbol. The chassis ground or frame ground does not by itself provide an earth ground for the equipment. However, its function is to connect the ungrounded metal frame of one piece of equipment to the metal frame of another piece of equipment that is already connected to an earth ground. Think of a chassis ground as an extension cord for the earth ground connected to one device, say your arc welder, to another electrical device such as your wire feeder. This is the symbol used to identify the chassis grounding screw on a piece of equipment. It is important that you understand how the earth grounding system works and what it does to protect you. In knowing this, perhaps you will be more careful to be sure the ground lead is always connected to equipment which you operate or work on. The ground lead carries no current most of the time, but when there is a fault, you need it, and it is important. The third type of ground, the welding ground, should really be called the work cable. Work cable is a better term because it avoids confusion with the earth ground and chassis ground leads. The function of the work cable is to provide a complete circuit for welding current to flow. You cannot strike an arc on a piece of metal unless the work connection is made. Without that connection from the welder to the work, the welding current does not have a complete path to follow.
Please remember the following points about electrical grounding. 1. The metal frame, chassis, or case of all electrical devices, such as your light fixture, arc welder, or table saw, must be connected to a wire which leads to a metal rod or pipe driven several feet into the earth. Connect the earth ground lead to the screw, which is colored green or marked with the earth ground symbol. Exceptions to this rule are double insulated equipment, which generally need not be grounded. Equipment connected with a plug to an outlet should be grounded through the ground pin in the plug. 2. If the electrical equipment with which you are working has a screw marked with the chassis ground symbol, then check to be sure that the chassis grounding lead from that point is connected at the other end to a piece of equipment whose frame is connected to an earth ground. 3. Before working on electrical equipment, always turn the input power to that equipment off, and use a tester or voltmeter to be sure that it is off.
If you would like further information regarding earth grounding, I recommend that you obtain a copy of the National Electrical Code and review the article on grounding. It is available at most libraries and bookstores. You probably have some awareness of the fact that carbon monoxide is a gas that can be dangerous if you breathe it. You may also be aware that it is carbon monoxide in engine exhaust that can make exposure to it dangerous. The purpose of this segment is to provide you with a basic understanding of the hazards of carbon monoxide and how to protect yourself against that hazard. Carbon monoxide is a gas that can be very dangerous, even fatal, if you breathe it in hazardous concentrations. Carbon monoxide has no color or odor, so you cannot see or smell it. Carbon monoxide is formed when fuel is burned and is caused by an incomplete burning of that fuel. The fuel may be natural gas, propane, gasoline, diesel, or almost any other fuel which is burned. The burning process could be, for example, a fireplace, an engine, or a furnace. It can also be created in arc welding and cutting, particularly if carbon dioxide shielding gas is used. We all breathe carbon monoxide from the exhaust of cars or other engine-driven equipment while at work, at home, or even walking on the sidewalk. The amount of carbon monoxide to which you are exposed in normal everyday life probably does not pose a serious risk to you unless you are in a situation in which the carbon monoxide is present in excessive concentrations in a poorly vented space. Examples of situations in which this might occur are an enclosed area, such as a garage or small shop in which an engine is running, such as a portable generator or a car. The level of carbon monoxide from the engine exhaust can build up to the point at which it begins to cause the symptoms as described above. If this occurs and you breathe a concentration that is high enough, it could result in serious injury or even death. You can determine if an exposure to carbon monoxide is hazardous by installing a carbon monoxide detector or by having a qualified person measure the level of carbon monoxide in the air with a meter designed for that purpose. You should have a carbon monoxide detector if there is any source of carbon monoxide in your home or workplace, like a fireplace, engine-driven equipment, or vehicles, or furnace or hot water heater that is operated using a fuel that is burned, such as wood, gasoline, diesel, or natural gas. For example, it is also a good idea to use equipment which burns a fuel which emits less carbon monoxide than gasoline engines, such as propane. The initial symptoms of low to moderate CO poisoning are similar to the flu, but without the fever. They include headache, fatigue, shortness of breath, nausea, dizziness. High-level CO poisoning results in progressively more severe symptoms, including mental confusion, vomiting, loss of muscular coordination, loss of consciousness, ultimately death. Symptom severity is related to both the CO level and the duration of exposure. For slowly developing residential CO problems, occupants and/or physicians can mistake mild to moderate CO poisonous symptoms for the flu, which sometimes results in tragic deaths. For rapidly developing high-level CO exposures associated with use of generators in residential spaces, victims can rapidly become mentally confused and can lose muscle control without having first experienced milder symptoms. They will likely die if not rescued. Fortunately, the steps you can take to protect yourself and your co-workers and family from the hazard of carbon monoxide are simple. 1. Be aware of situations in which carbon monoxide may be present in hazardous concentrations due to the burning of fuels, particularly when engine-driven welders, generators, or other equipment is being used. 2. Only operate engine-driven equipment outside where the exhaust cannot become concentrated. Never operate a portable generator or any other gasoline engine-powered tool either in or near an enclosed space such as a garage, house, or other building, or near an air intake for an enclosed space. Even with open doors and windows, these spaces can trap CO and allow it to build lethal levels. 3. Know and watch for the initial symptoms of overexposure to carbon monoxide, such as headache, nausea, fatigue, and dizziness, when working around engine-driven equipment. 4. If you believe you may be overexposed to carbon monoxide, do not try to determine the cause of the problem. Immediately go outside where you can breathe fresh air. Be sure that any other persons in the area also go outside. If you have any of these symptoms, immediately call 911 or seek medical attention. Do not return to the area until it has been confirmed that the level of carbon monoxide does not pose a health hazard. Many welders are mounted on a trailer so they can be easily moved to the work site. Trailers are generally very durable and reliable if they are installed and maintained properly. It may be easy to ignore the simple maintenance that a trailer requires, but try not to. Regular maintenance of your trailer is as important as maintenance of the tow vehicle. In this segment, we will review a general list of things that should be checked and rechecked before operating a trailer. Because there are many different types of trailer equipment and tow vehicles, this list may not cover everything which applies to your specific tow vehicle or trailer.
Use the following checklist as a guide before you tow and if you need to recheck your tow. Check these items before towing a trailer. Trailer capacity must be adequate for the payload. Do not overload the trailer. Check the manufacturer's specifications and the capacity plate on the trailer. Tow vehicle and hitch capacity. Check capacity and serviceability of the tow vehicle and hitch. Tongue weight. Always maintain a minimum tongue weight of approximately 8% of total trailer plus payload weight. Follow the manufacturer's instructions when assembling trailer and mounting welder to trailer. The welder must be mounted to the trailer so there is a proper amount of tongue weight. If the welder is mounted too far back, the tongue weight may be too light, which may cause the trailer to sway or affect stability when towing or when it is on the work site and not connected to the tow vehicle. If the welder is mounted too far forward, the tongue weight may exceed the capacity of the hitch or coupler. Hitch in connection to trailer. Be sure the coupler is secured to the ball or other hitch on the tow vehicle in the locked position. On some types of couplers, insert a nut and bolt or other locking device into the hole in the coupler so it won't accidentally pop open, possibly allowing the trailer to become disconnected from the hitch ball. Safety chains crossed. Install safety chains on trailer before towing above 10 miles per hour or on public roads. Be sure the safety chains and emergency brake cable are in place and properly secured to the tow vehicle so they won't fall off. The chains must be sized for the weight of the trailer and payload. The safety chains must pull and support the load if something goes wrong. Tires and tire pressure. Inspect all tires for damage or wear. This includes the tow vehicle's tires. Tire pressure should be set to the trailer or vehicle's manufacturer's recommended pressure and not greater than the maximum pressure on the tire. Be sure the load capacity marked on the side of the tire is not exceeded. Wheels, bearings, lug nuts. Check the condition of the wheels and bearings. Check to be sure all lug nuts are tight. Be sure bearings are serviced and have grease. Bearing failure can cause a wheel and tire to separate from the trailer. Trailer lights. Do not tow trailer after dark without lights. Check to see that the trailer wiring is properly hooked up and working. Is the connector on the trailer wiring the same type as on the tow vehicle? Have a partner stand behind your trailer and tow vehicle to double-check that all your lights are functioning correctly. Leave enough slack in the light wiring and secure it in position so it will not be disconnected or damaged when turning corners. Welder fuel shutoff. Most engine-driven equipment has a shutoff in the fuel line or at the tank. Always shut off the fuel when trailering to prevent fuel leakage. Welder, trailer mounting hardware. Make sure you are towing the trailer in a level position. Ensure that the lug nuts on the tow vehicle and trailer are tightened to the correct torque and setting. To find the correct torque, refer to your owner's manual and use a torque wrench. Make sure the trailer jack is raised and locked in place. Jacks that are dragged on the road are potentially dangerous and can also damage the jack, trailer, or tow vehicle. All equipment on the trailer should be properly secured. With the trailer hooked up and ready to tow, make sure all mirrors are properly adjusted. Warning: unstable or improperly used trailers may cause injury and property damage. Inspect and maintain trailer, tow vehicle, and hitch before towing. When operating a tow vehicle, tow at a speed at which the trailer is stable and does not sway. Use the mirrors on the tow vehicle to be sure the trailer is towing properly. If the trailer is not stable, or if a problem develops or something does not feel right, don't ignore it. Do not continue to tow the trailer if you think there is a problem. Immediately slow down and pull the trailer off the road in a safe location and recheck the trailer and tow vehicle. Fix the problem off the road. Always review the manufacturer's instructions for the tow vehicle, the trailer, and the welder or payload before installing, maintaining, or operating a trailer. Check local laws for specific trailer or tow vehicle requirements, such as brakes, lights, or fenders.
Arc welding in a confined area, such as a boiler, tank, ship hold, or similar confined, enclosed, or restricted space. Bear in mind that all the hazards associated with normal arc welding are amplified. Therefore, special precautions must always be taken and other procedures followed in accordance with specific requirements that apply, such as with confined spaces under OSHA's 20 CFR 1910.146.
The definition of a confined space, according to OSHA, is 1. That it is large enough and so configured that an employee can bodily enter and perform assigned work, and 2. Has limited or restricted means for entry or exit. For example, bins, silos, tanks, vessels, hoppers, vaults, and pits. And 3. Is not designed for continuous human occupancy. In a confined space, there is a greater danger that flammable gases may be present that could cause an explosion. Also, the walls of a metal enclosure or space can become electrically energized and become part of the circuit, presenting an electrical hazard to the welder or other entrants. Fumes from welding or other hot work can accumulate more rapidly and concentrate to dangerous levels in enclosed or confined spaces. Fumes generated from the work itself and/or the gases used for welding and hot work can also have the potential to displace or force out breathable air, while also potentially consuming and reducing oxygen concentrations to below safe levels. Per OSHA 29 CFR 1910.146 D.5.3, the following atmospheric hazards must be assessed for any confined space prior to entry. 1. Test for safe oxygen levels. 2. Test for combustible gases and vapors. And 3. Test for toxic gases and vapors. OSHA has many other specific rules that apply to entering confined spaces. Employers must have a written confined space entry program that includes specialized training for employees that enter confined spaces, serve as attendants to those entering, and for those who supervise confined space entries. They must also have a written entry permit process that includes a hazard assessment and specific entry procedures that employees must follow in order to safely complete assigned work. Never enter a confined space to complete welding or hot work without having the necessary training, and always follow the applicable precautions and procedures outlined in your employer's confined space entry program. When working on an elevated platform or a lift, additional safety considerations should be made. First, follow your company's fall protection program. Wear and secure your harness. Welding sparks will disperse further when working at heights.
In addition to the topics discussed throughout this welding safety video, it is important to remember to keep in mind some general guidelines to maintaining a safe work environment. Always maintain the guarding that comes with the machine or hand tool as it was intended by the manufacturer or the company providing the equipment. Put tools away after each use so that they do not become an obstruction or a trip hazard. Keep your work area clean and free of debris. This can help to minimize trip hazards and fire hazards. Always understand your role in any emergency. Identify appropriate evacuation routes and know your rally point. Be aware of your surroundings and the types of work those around you may be performing. Remember to be aware of the environment you are working in. Be careful not to burn yourself. Welding generates a lot of heat. Don't become distracted while you are working. Focus on your task. Electric current flowing through any conductor causes localized electric and magnetic fields, EMF. For example, when you are welding, the welding current flowing through your arc welder and welding cables creates an EMF field near the welder and the welding cables. Various studies have been conducted in order to determine if exposure to EMF causes some health effect. It has been suggested by some that exposure to EMF, for example from electric utility power lines, microwaves and cell phones, may cause various health effects, including cancer. To date, these health effects have not been confirmed by studies. However, EMF fields may interfere with some pacemakers, and welders having a pacemaker or defibrillator should consult their physician before welding. Exposure to EMF fields in welding may have other health effects which are now not known. It is prudent for you to use good practice when arc welding to minimize your exposure to EMF. All welders should use the following procedures in order to minimize exposure to EMF fields from the welding circuit. Route the electrode and work cables together. Secure them with tape or tie wraps when possible. If the cables are routed together, the EMF field at that point is reduced. Never coil the electrode lead around your body. This practice should be followed for many reasons, including minimizing your exposure to EMF. The closer you are to the source of the field, the greater your exposure will be. Do not place your body between the electrode and work cables. If the electrode cable is on your right side, the work cable should also be on your right side. There is an EMF field at and between each cable. Connect the work cable to the workpiece as close as possible to the area being welded. Current flows through the workpiece from the welding arc to the work cable clamp. For this reason, there is an EMF field at the workpiece. Using a work connection close to the arc is always good welding practice because poor work connections are a frequent cause of problems with arc welding. Do not work next to the welding power source. The input and welding current flow inside the welder and create a localized EMF field near the welder. In addition to the above precautions, You may further minimize EMF exposure by welding at the lowest DC output settings acceptable for your welding application. This is particularly important if you have a pacemaker or defibrillator. In any event, if you have a pacemaker or defibrillator and wish to continue to weld, you must talk to your physician and follow the advice given. Your physician may want to contact the manufacturer of the pacemaker to obtain their recommendation about arc welding. In some cases, your physician may advise against continuing to weld.